virtualization on top of those servers. Okay. Okay. But the virtualization that they did, and you will be studying how virtualization is done in the next semester. But when you do virtualization, initially there was no hardware support. So you had to basically do virtualization through software, which killed the performance of the server. In response to this, you got hardware modifications which allowed you to do virtualization in hardware. Okay, so you ended up speeding up the virtualization, which meant that you can do a lot more work within the same server, right? And there is also a lot of development in data center networking to allow for fast access, right? Anyway, long before, I don't know if Chakravarti sir touched upon it as part of IO subsystem, but there's something called software-defined networking, which came in the data centers, right? Which basically allowed you to do the networking in a much better fashion. Then I don't know whether sir talked or not about IO subsystem. There is something called storage area networks, which came long ago, where the storage, the disks, the hard disks are all associated with a different network in the data center, and you access that storage via the network, right? Via Ethernet. So it's a distributed storage that you are talking about. You're no longer talking about hard disks associated with the computers. Okay. So, various systems developments led to better and better ways of handling big data. And therefore, you ended up with having the capability to do this, deep learning and so on. And they have reinforced each other. The requirements of deep learning or big data have actually influenced the development of better processors, better algorithms in OS, in networks, in cloud computing, all sorts of things. So they have a very strong, synergy, I should say, between the applications and the systems at this point. In fact, you would think that systems, development has reached its peak with Unix in some sense, and there was hardly any development after that in operating systems. But if you look at things now, actually, in some sense, the last few years, at least the last decade, has been a very exciting time for systems programming. Okay, people had to move anyway from uniprocessor operating systems to multiprocessor operating systems. So you have the symmetric multiprocessor kernels. All of the operating systems today are SMP kernels, which take advantage of the multiple processors. Not very effectively, but definitely they take advantage of them. Okay, and you have read multi-threaded programming, right, in your OS. Synchronization between threads is the most difficult programming to be done. Am I right? I don't know how well you have experimented. I know Chakravarti sir makes you do a lot of programming in synchronization. Writing multi-threaded programs which are properly synchronized is one of the challenging projects you can ever take up. Okay, so because that is such a challenging thing, but on the other hand, you have all these multi-core systems which are different from multi-processor systems. Why? Because these cores are on a single chip. Earlier, you had one processor per chip, but now you have multiple processors per chip. So what we see today are all what are called multi-core systems. If you really want to take advantage of multi-core processing, then you have to write multi-threaded programs, which are well, written to take advantage of these multi-cores. But writing such programs is not easy to do. very few systems programmers can write such good programs. So there has been an effort to reduce the complexity of developing such applications through what is called as transactional memory. You have done databases. What is a transaction? Now I'm actually waiting for an answer. What is a transaction in database terminology? Why the deafening silence? Is anyone able to hear me at all?
Yes, ma'am.
So what is a transaction?
It's like work done by the management system towards the database.
I'm sorry. I'm really sorry. Like, I'm also looking at chats and answers. Come on, you can't give such answers. I really feel bad at the end of, your integrated MTech here in University of Hyderabad. If you people can't answer basic questions on databases and all, it will be very embarrassing, seriously. What's an atomic operation?
It is a basic operation which execution of any program which changes the database or any function which.
Which question are you answering? Atomic operation or transaction? Okay, atomic should be treated as a single unit. More precise answer that OS gives you. I'm not saying your answer is wrong, but
ma'am, like atomic operation is an operation which is executed without any interruption.
Interruption, yeah. Okay. What's a transaction?
It's a set of atomic actions.
It cannot be a set of atomic actions. I'm sorry. If you say set of atomic actions, it means that you can be interrupted between the atomic actions, right? So if you get interrupted between the atomic actions, and I don't think transaction says that operations have to be atomic.
Any operation that changes the database?
No. Set of database operations is not a transaction. It has a very specific, property. Otherwise, any database operation is a transaction. That's not true.
Asset property.
Sorry?
Atomicity, concurrency.
Series of atomic actions will also mean that you can be interrupted between the series of atomic actions, right? So then what happens? What's the standard example people use for a database transaction discussion?
Movie ticket booking.
Do they? I thought banking operations are the most famous and favorite things, because if you transfer, say, some amount of money and it's not properly handled, you will actually end up probably transferring a lot more than you wish to. It's not a transaction.
Yes.
How? Okay, a transaction is a set of operations that can't be interrupted. Unfortunately, what is ACID properties? Because
Atomic.
I haven't done databases since my BTech, which is like whatever, 40 years ago.
Atomicity.
There are a set of 4 properties: atomicity, consistency, something else, and durability.
Probably integrity.
Isolation.
Isolation.
Hmm?
Isolation.
Isolation.
Isolation. Okay. Okay, so a transaction is a set of operations that can't be interrupted. Can you actually have an operation like a banking operation where you're transferring data from one account to another, where you can guarantee that it cannot be interrupted? Interruptions can happen because of 10,000 things, because we have seen how many things can go wrong in networks.
Yes, ma'am. Yes.
So then what's the transaction? Well, and you correct me because you people are supposed to have done databases recently. Like I said, I haven't read the database textbook in almost 40 years. So a transaction is a set of operations, all of which have to be completed, or if you are interrupted, you have to roll back the operations to the state you are in before you started the transaction. That is, you basically undo any operations you have done. Am I right or not?
Yes, ma'am.
You don't know. That's what I would say. Please go and read databases properly, because a lot of features of databases, which is one of the oldest theories of computer science, are being used extensively in operating systems and hardware nowadays. Okay, so don't ever ignore, theory of any part of any course. That's what I would say. And so they have what is called as transactional memory now. So when we say, okay, this is basically how it works. When you talk about synchronization, what's the problem? I know I haven't anything to. Yeah, this is the actual definition. It's a set of operations that can be either fully done or nothing is done. So if you are done partway, you roll back. Okay, that's basically what's a transaction. Now, if you think about synchronization, what's the problem? You are interrupted at a particular point, right? If you're doing some operation, if lock equal to 0, lock equal to 1, right? Then you are interrupted between checking that lock equal to 0. So you find lock equal to 0 and you proceed to set lock to 1. In between these two statements, you are interrupted. Somebody else, right, a multi-threaded program, another thread takes the control of the processor, checks that lock equal to 0 and sets lock equal to 1. So both enter the critical section at the same time. This is what happens. I don't know if you still remember your OS synchronization, but essentially in very crude terms, this is what happens. Am I right? Now, this can happen only at some times, right? You are exactly interrupted at one point and another takes over and enters the critical section at the same time. This is not something that happens necessarily. It happens maybe only once in, say, 10,000 runs, okay? Which is why you have inconsistent results without synchronization. Okay, you get good, correct answers most of the time maybe, but incorrect answers occasionally here and there. It's inconsistent. It is not consistent. To ensure that this inconsistency doesn't happen, to ensure that you don't get this wrong answer once in so many runs, you have to do the locking with semaphores or mutexes. But in most of the time, the mutex or semaphore is not needed, but you are forced to do it because of the, few times it happens. Now, the problem with using a mutex or semaphore is it is going to reduce the performance of the application, because you cannot allow multiple threads to proceed. So if you write a course critical section where the critical section consists of many instructions, then the thread simply is blocked, waiting for the other thread to come out of the critical section and unlock before it enters its own critical section. So the performance is very badly affected. To speed up the performance of multi-threaded programs as well as make coding easier, the concept of transactional memory has been introduced. There is a software transactional memory library. It's also implemented in hardware today, right? Intel's Haswell processor was the first processor in Intel family which introduced transactional memory in hardware. What does it do? You write locking in your code, but when it is actually scheduled on the processor removes the locks and schedules the threads without the locks so that they can proceed in parallel without being held up by the other thread. But if the two threads enter the critical section simultaneously, it is able to detect, the processor is able to detect that these threads have entered the critical section simultaneously. And then what does it do? It is transaction. So it rolls back. Whatever the threads have computed until now, it rolls back to a safe point and then, schedules them sequentially. Okay, so this is what is being done, not now. In 2013, I think Haswell was released. So it's 7 years since such processors have been released, and which speed up the performance of the applications, especially the multi-threaded applications. So this is the sort of incredible, what should I say, developments that are happening in processors. In addition, of course, you also need a lot of development in systems, which is also happening, but similar, what should I say, developments have not happened in system software. Like they are working on parallelizing compilers. So you write your sequential code. Don't bother, break your head about writing multi-threaded synchronized programs. The compiler will parallelize your code. Okay, so things like that. And it's very interesting the way the various advances have happened in processors. And you will see when we study advanced architecture, you will see that they do what is called a speculative processing. In fact, I was so stunned when I started teaching in 2014 this course, right? Because I had never studied architecture after my BTech. So they actually say, okay, they expect that this instruction will be executed and schedule that instruction. They do out of order execution of instructions and still are able to produce correct results for you. The sort of things that they do inside processors to give you the sort of performance you're talking about today is just incredibly beautiful. So, of course, they have multiple processors, so they have to optimize a lot of things to make sure that these are taken advantage of. But multiprocessors also bring with them their own set of problems which have to be solved. So there is synchronization at the hardware level that we need to also talk about, and so on. So But what we are thinking this semester is that we will see how it goes. We are actually scrubbing off some parts we feel are not the most important concepts, and because we are not sure how well we'll be able to handle the things. If we do very well, okay, we'll include items which we thought we will not cover. But for now, we are starting off with the assumption that we won't be covering some small parts of the syllabus. Okay. So, any questions? Because the PDF I have put up actually is not just trends in computer architecture, it is trends in the entire systems that led to, a positive feedback between the applications and the system software. I talk about how the PCI, which is the peripheral computer interface, right? Express has changed a lot of things. In fact, in the data centers, the servers are not connected using Ethernet also. They're connected using PCIe, which is what is quite stunning. Hey, what is no, ma'am? Okay, no questions, you mean, Krishna?
Yes, ma'am.
Okay.
I just wanted to
I
like
was
interrupt the
wondering,
flow.
like, what you were saying is I didn't understand a word of what you're saying. So,
Sorry, ma'am.
because I'm not, I don't have anything really, I'm just playing, right? And so.
Yes, ma'am, when you
Yeah, so
mentioned,
PCI,
sorry, ma'am.
yeah, go
So
ahead.
yes, ma'am. Like about PCI, ma'am. Ma'am, like, are they like? Is there like like a particular express slot that they're using? Like, ma'am, I know like GPUs they use PCIe 16 lane channels, and so is it like specific to like only some channels, or they're like allowed to use the entire width of the motherboard on the server?
I haven't actually explored PCIe so well, but essentially PCI was a bus, right? Exactly like Ethernet originally was a bus, I told you. And I think Kameshwari's talk on Ethernet was very detailed, I thought, 10 base T versus, the 100 Mbps versus the gigabit Ethernet. If you look at how it evolved, Ethernet was originally a bus-based, topology and technology. Then as we moved to the gigabit Ethernet, it became point to point because it became a switched thing. So it became full duplex, multiple concurrent connections and so on. That's exactly what happened with PCIe from PCI. So maybe, I'm guessing here, I have to study to answer your question, but I'm guessing that when they say 16 channels, I guess they mean that 16 concurrent connections can happen probably.
Okay, ma'am.
And GPUs are basically what is called as data parallelism, right? They were originally developed for graphics, where you have all these translation, rotation, and in fact, when you talk about graphics, you also talk about one frame to the next. You are having movement, right? When you have movement, essentially it's translation, rotation, and so on, which causes the movement. And you are displaying one frame after the other to give the illusion of the video. So the crunching can be done on one frame while another frame is being displayed, right? So in the video controller, especially, like I said, there are a lot of controllers and they had a video controller. They replaced the video controller with the GPUs originally. And then they discovered that actually you can make GPUs do regular work, which is based on data parallelism. So something like image processing, for example, is very, very amenable to data processing. data parallelism, right? Because what do? Most of the algorithms in image processing, say take a 3x3 window and replace the central pixel with this formula sort of a thing. And you can divide your image into multiple parts and give these multiple parts independently to different processors, and then combine them, results from all the processors. So it's very, very amenable to data parallelism. Same algorithm runs on all processors, but on different data. What we will see as part of our advanced architecture course is what is called as instruction level parallelism, where you basically have an assembly line like Ford created for cars, right? You divide the entire instruction execution into different subparts, okay, and schedule these subparts, in different stages of the pipeline, so that you now get multiple instructions simultaneously being executed. Okay, that's what is pipelining. Have you done that in your COA? Because supposedly it's a part of COA syllabus actually. We make no assumptions here. We actually cover instruction set architecture, which is supposed to have been done in COA. We also do memory hierarchy review. We also do pipelining basics, and then only go on to the more advanced topics, which is one reason why we can't cover GPUs and warehouse scale computers. If COA is properly done, then advanced architecture can do even those advanced features. But I have found that it's very difficult to do that even with MTechs or anyone. So the plan will be, as I have put up, if you have seen, the topics are already up on the Moodle page, so no material is up on the topics. So yeah, so from my side, I'm done, but ma'am can also probably have something to say.
No, nothing.
Concurrent access to global resources by multiprocessing systems lead to problems. Here it will if you do not do synchronization, right? So there is hardware level synchronization that exists, which is basically your atomic instructions, right? Support for atomic instructions, and which are used by the operating system to construct synchronization primitives which you use in your application. So if you don't use synchronization primitives in your multi-threaded applications, then you can get into very serious problems in multiprocessor systems. Rukma.
Anupama. Yeah. The only thing I would like to say is that for the next class, they'll be having a quiz on COA. Maybe from the next week, we'll start into a topic-wise discussion of the topics that you have set up in Moodle.
Yeah, in the meanwhile, please let us know what is the model of teaching you will prefer as a majority. People who want asynchronous anyway can get the asynchronous. That's no issue.
It's created.
What, Bansi?
Quiz man. Is it created? Mark.
Quiz.
Not this quiz. From the next week, it will be.
Don't bother about the grades. Just
No,
do it.
no.
Okay.
People asked in the group.
Yeah, this is only to see the student response or how the functionality of Moodle is happening. This quiz will not be graded. Oh,
Okay. So yeah, I mean, the reason for having a quiz is to see, where you are with respect to COA. That's all. It'll be good for you to go over that COA review video that ma'am has found and put up for you people to go through. Hopefully that will give you the brush up needed, and you can do the COA quiz, which will also tell us how to handle this course. Okay.
yes. And there is lot of information kept. I have added 2 videos. Ma'am have kept lot of information. Even I haven't gone through them. So go through that.
Okay, ma'am.
See, treat the whole of this as a way to expand your knowledge of how is your computer working, right? You should have curiosity. You should, in fact, as computer science students, where do you distinguish yourself, right? Everyone in the world, I'm sorry to say this, but everyone in the world can write a deep learning program with Python. If they know how, the difficult part in deep learning is modeling, where you need to know your mathematics. Once somebody gives a model, writing the code in Python is no big deal. No one in the world can write systems programs except computer science people. You should feel proud to learn how systems work. That is where you are actually different from everyone else. Okay. So, approach the problem and the subject with excitement.
Sure, ma'am.
Yes, ma'am.
Actually, I found some nice videos from Carnegie Mellon University, but I thought maybe they'll be too high for our students. So I just shared it with Rukma saying, okay, at least you and I will learn from these videos. Anyway, this is the course I loved most in teaching. Let me put it that way. Because I learned so much while teaching this course. So it challenged me as very few courses in the world have challenged me. And I learned so much and I had so much fun learning it. So I'm actually very excited to come back to teaching this course. Okay, I think I'm done from my side. So our actual next session is on Saturday, 12 to 1, I think, right, Rukma?
Yes.
Yeah. So these are 2 scheduled slots they have given us. We are trying to stick to them because we are not at all sure how the sessions are being held by other faculty. We don't want to, otherwise we'll prefer actually this to be 2-3 1-hour sessions. 2-hour session
Yeah.
is exhausting for us also, you also, but
We'll see. Maybe in a week or so, we'll see some timetable changes.
yeah. Okay then.
Shall we call it a day?
Yeah.
Okay, ma'am.
Right then. Thank you, guys.
Thank you, ma'am.
Thank you, ma'am.
Thanks, ma'am.